In today's podcast, we talked about Rust language and its relevance for the embedded systems engineer. We specifically discussed on some features of the language like mutable, immutable stuff, borrow checker, borrowing ownership, the fact that Linux kernel got Rust language, it allowed modules written in Rust language. And then further on, we discussed on C and Rust and the combination of it. And, should a embedded systems engineer consider learning Rust and questions of those nature. So hopefully you'll enjoy this podcast and let us know in the comment section how you liked it. And over to you. So, Rajat, what is Rust and why should I care about it as an embedded engineer?
Okay, so Rust is not a very new language. It has been there for years. It actually started at Mozilla, where they
Mm-hmm.
wanted to, develop a new core for the browser. But why should we care about Rust? So the thing is, if you go back and look at the C and C++, right? So they
Mm-hmm.
started with a methodology that you should let develop the power should be in the hand of the developer, and you should never
Right.
restrict the developer from doing anything. And
Right.
there were a lot of freedom to the developers around it. So what happened is when people start playing around memory, right? If you look at C specifically, uh,
Mm-hmm.
you get a memory and then it is developer's responsibility to free it. And what more important is, it is developer's responsibility to track when a memory is getting allocated and when a memory is getting freed. So what happens in a lot of scenarios like this is like what you free up a memory, somehow you free up a memory because not a single developer is writing everything, and you unknowingly free something, or let's say you are getting you expect some memory to come out of an API, but
Mm-hmm.
for some reason malloc was not able to allocate that memory,
Right.
and it
Right.
returns a null. But if you just
Mm.
make an assumption that always a memory is going to come out and not check with null, which is a very common error in C, you end up in
Right.
faults and segmentation faults kind of things. So
Right.
this was becoming a major problem because, and I guess there was a survey from Microsoft as well where they said that 70% of the issues that say they see in the Windows are related to
Yes.
memory.
Right. Well, the
And
actual survey, I suppose, was 70 to 80% of the bugs that they get are
yeah,
reported, bugs or vulnerabilities that are reported in the operating system are around memory management.
yes.
Right.
Actually, there was even a very big bug in their RF, remote procedure call RPC
Mhm.
communication, where somebody didn't check the length of the string and just started copying it without that, and people were able to, hijack systems from it using that
Because they could
vulnerabilities.
get access to the shell.
They were able to corrupt things more
Oh,
than
wow.
so. It was
Nice.
like even though the string was allocated 128 bytes, the
Hmm.
call expects that to be, let's say, 128 bytes. It may not be the real number. People were
Hmm.
able to send 512 bytes into it. And since
I
there is no
see. I
bound
see.
check, it was just, since it is just a pointer, it was corrupting the memory ahead of it.
Understood. It was like writing over the memory that did not actually
Yeah.
belong to it. Fair. But then, okay, let me just maybe reiterate. So we are talking about memory management scenario that in
Yeah.
case of C and C++, it's kind of the developer is trusted a lot more, the programmer is trusted a lot more, and
Yes.
the language assumes that they know what they're doing. And turns out because you have so many people working on the same code base, it's hard to track when the memory is allocated, when it's freed, and so on and so forth. And bugs are easy to slip. Okay, then how does Rust address this? I'm assuming Rust addresses this.
Yeah. So Rust goes into an exact opposite direction of C and C++ ideology, where they are like, you don't know anything, let compiler handle these things.
Okay.
And
Okay.
so if our API is supposed to, so Rust doesn't have a very straight concept of null. They go
Okay.
into another direction of handling this. So what they do is, like in
Well,
such
first off,
scenarios,
wait, hang on. First off, what is null? Just so that the
Yeah.
audience is on board as well.
Okay.
What is null?
So null null is just a void pointer to zero. People came up with to check when you didn't get the memory you were expected to get. And funny part is if you read about Rust, the point they say why they don't support null is an article from the inventor of null itself who says null is his $1 billion mistake. And he specifically highlights that it was so easy to say null is equal to void star zero that he could not
Yeah,
restrict himself from putting it over there, and that became
right.
a mainline thing.
Yeah, yeah, yeah.
Yeah.
Rust has a very unique approach towards it. So what Rust says is, you know what, using compiler. So there are two ways to handle this, these memory kind of problems. One is you have something called a garbage collector, which tracks the
Right,
lifetime and reference counting of these pointers, and based on it, it frees it up on the back
right.
and it automatically manages this memory. This is what Python, Java, etc. does on the back. But
Hmm.
here's the problem: this is an extra software running on the back,
Right,
which is a problem for system programmers because
right,
it directly impacts performance. On a
right.
periodic basis, a thread needs to run that should initiate the garbage collection procedures,
Yes.
free up the memory, and then give control back to the main thread. So
But
it was
also, then
very,
if we, sorry to
yeah.
interrupt, but I wanted to add this that if we are talking about running a separate thread to do garbage collection, so to speak, that mandates that you cannot have bare metal code. You need a scheduler of some sort.
Mm. Mm.
You
Yeah,
need
you
on a
need a schedule.
controller. Yeah.
Yeah.
Well, in that case, you can have
Interrupt.
we call it a super while loop in which after
Okay.
all the threads are executed, you can call the garbage collector at the end,
But
and then
again,
garbage
that
collector executes and then go back.
sure. But then wouldn't that kind of an architecture require that none of the threads have a while one? Like they
Yeah,
have
so
to yield
yes,
at some point, right?
Mm.
yes. Similarly, you can have so if you don't want that kind of architecture, then you move on to event-based architecture where it is
Fair.
interrupt-based. Then you can have a timer running on the back, which on a periodic
Right.
basis calls the garbage collector.
Fair. 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 Yeah, I think that makes sense.
Uh,
So you can still write
yeah,
bare metal code, but you also need an interrupt handler in that case, like a
yes,
mandate.
yes,
Fair.
yeah.
Okay.
So
Go back to Python and Java and garbage collection.
So that's what they do. But in certain points, you don't want this kind of system, taking over your performance metrics and control.
Right.
So
Right.
that's why even though people knew that C++ has so many problems, people still continue programming in C++ and developing system applications in C++
For
because they
C++,
don't want
you're
something like
saying,
garbage collector.
Mm.
I see, I see, I see. Okay, okay. So the garbage collector is what stops the C++ folks, or like
There
it's a reason why they continue to write in C++.
So there, yes, it's a reason because they have a control system, a complete control of the system. It's not
I
specifically
see.
garbage collector. There are other things as well
Mm.
that stops them. For
Hmm,
example,
hmm.
Python to C++, it's six-fold decrease in performance.
Right,
As
right.
per, I
Mm.
guess there was a survey of time, energy, and something between
Yeah,
programming
and
languages,
Python
and Python performed really badly in that graph.
badly. Yeah. Well, at this point,
Yeah,
I want to kind of highlight this that, there is an MIT lecture around performance that compares matrix multiplication, like a big ass matrix being multiplied, right? So matrix multiplication in Python, and then, using like they use different languages closer and closer to hardware down to special instruction in the ISA, and the performance goes from like 6 hours to multiply the matrix down to 3 milliseconds or so. So they're able to extract that much. Or rather, Python is that slow. Yeah, just to prove the
yeah.
point.
So Rust takes a unique approach where it says, you know what, we understand you guys don't want a garbage collector, but memory
Hmm.
safety is also crucial. So
Yes.
what if we give you a very smart compiler that can track your memory and
Mhm.
tell you in compiled time where you can end up in deadlocks or bad situations.
Mm.
And that's
I
what
see.
the Rust compiler is about. So what it does is it
It
says
can
if you write a
detect.
code in,
It can
yeah,
detect
so what it
deadlocks.
says, uh, it can, they have concurrency models as well in Rust,
I see.
and basically it can detect runtime like race conditions
I see.
where
Okay.
a
Okay.
possible race condition can happen.
Right.
Okay.
So basically, what the Rust compiler says is if you write code in certain ways, as instructed by the compiler, we can guarantee you that you may not, even if you end up in panic, you will end up in gracefully in panic. And you
Okay.
will not have any memory. You can be sure that your code is free of memory related issues.
Mm, mm, fair.
So, and it's a big concept around ownership and borrowing. What the
Mm-hmm.
Rust specifically says.
Mm-hmm.
But that's the whole point of Rust. And now the question comes is, so when we talk about C being used in embedded systems, C
Mm,
is not used only to develop end applications. C is used in a lot of places which may not go into production at all.
right.
For example,
Right.
whenever if you are working in a semiconductor industry,
Right.
validation engineers use C to write their validation code. So
Right.
safety is not their concern. They are not concerned about safety or something. And
Right.
what they want is they can just take a pointer, read a memory, and whether they can, they want a quick debugging. Similarly, verification engineers mostly they want to just write to certain registers very fastly, and that's why they are
Right.
taking C and not going into the UVM
But true,
things.
true, true. I suppose their intention there is to exercise
Yeah,
the hardware as much, and even if
exactly.
there is failure, then nothing catastrophic happens. It's like you
Yeah.
fix your software, run it again. It's not out there in production. Yeah.
So the main question that goes back, and Rust is a very nice language, and I would like to highlight there are two ways to write Rust. One,
Okay.
you can write Rust like a C language, and the second, you
Okay.
can write Rust like a Rust language.
Rust language.
So
Okay.
Rust
But
like
but
C language,
before you go
yeah,
there, how about we talk about few of the features of the language that you know of? I know
Mm.
the concept of mutable, non-mutable, everything
yeah,
is unmutable unless specifically called out by the developer,
yeah.
so on and so forth.
So Rust goes behind the fact is that everything is private and immutable by default. So
I see.
if programmer didn't specifically tell that this can be mutable or this can be used by someone else, it is
Right.
private and immutable. While
Right.
C takes another approach. Unless programmer tells it's private, it's public.
Fair. Makes sense. Yeah.
So and similarly, unless programmer tells it's const, it's not const. You can modify it.
You can modify it. Yeah. Yeah. Yeah.
So I have a
Fair.
question where, so since Rust does a lot of compile time check, so do they need the mutex semaphore, these kind of concurrency enforced mechanism?
Yeah, so these are independent of language, right? These constructs are concepts of the operating system, and the Rust is still running on the same operating system, right?
So if you
So
Okay,
had
but
you
like
still
two.
need mutex around it. You still need mutex around a condition that around a code that can be accessed from multiple threads. I have not. I would still restrict commenting on it
Mm.
because I have not browsed it because
Right.
I
Fair.
don't use Rust to write system applications running on operating systems. That's not my job majorly.
Fair.
So
We are not there yet in terms of
we
using
are not
Rust.
there yet.
Yeah.
yeah.
So
So,
the problem goes back to the fact is uh, embedded engineers, like at least I am a low level programmer, so I write code that creates thread, not uses threads.
hmm,
I write the
it's a
thread
very good.
library. So I
Yeah.
cannot I cannot have a mutex and I am the one writing mutex. So
True. Makes
I
sense.
write
Makes
low
sense.
level constructs on it. So I don't
Hmm.
assume that there is a construct available to me.
Hmm.
So
Okay.
concurrency in lot of senses for me in Rust is I have to implement the concurrency. So I implement the RTOS. So
Right.
the concurrency model comes from me. And there
So
are
Rajat,
other thoughts around it. Yes, there.
so personally, I don't understand like Rust a lot, But since you mentioned that there is some ownership concept, so I was thinking maybe
Yeah.
only one, thread or a program would have the ownership of to
Exactly.
change the variable,
Oh,
and that's why
yes.
you mentioned
Exactly.
that.
Yes.
I think
Yeah.
Rajat
So
somewhere
maybe true. Yes.
hinted at the borrow checker and the
Right,
Yeah.
concept of borrowing.
right.
I think let's do this. Let's come to that in a while. But Rajat was
Mhm.
mentioning about two ways of writing Rust. One is the
Right.
Rust way, and one is the C way. Let's wind up on that.
Yeah.
Go ahead, Rajat.
So, you can so Rust provides something called a unsafe block. And
Mm-hmm.
what basically tells is if you put something over here, Rust compiler won't check everything what it should be checking.
Right.
And and at that point, you can do whatever you wanted to do in C. You can take a pointer and modify anything. You can take a pointer to something and modify it. But I still see a value over there.
Mm-hmm.
Like it doesn't make sense for me that somebody is writing so much unsafe Rust. But again, if you're doing a low level
Right.
development, so if you look at
Right.
a hardware, if you look at a peripheral is a single block of memory that can be accessed by anyone. So
True.
you cannot have a direct, concept of ownership and borrow over there. So what
Right.
Rust recommends is what if we develop structures around it that can follow ownership
I
on
see. Okay. And by
single
structure,
and
do you
it
mean do you mean the C structure or the
C
conceptual?
structure,
I
the
see.
concept of structure, the concept of
I see.
structuring things. And this goes back to, I guess, one of the solid principles where they say single point of contact, where only
Ownership.
one API
Mm-hmm.
should be able to, a single point of ownership.
Hmm.
And so that's what Rust methodology is. And the thing is, we all follow that in C as well. Whenever you are writing drivers, only driver can modify that set of registers in
Right.
UART, right?
Right. Right.
But
Right.
the point that where C goes wrong is C allows you to take a volatile pointer and modify it
Hmm.
from
Hmm.
any
Yes.
location you want. While this is possible in Rust, but you have to specifically guard it with unsafe, which acts as a marker to other people that okay, somebody is doing something which he should not be doing in Rust.
I
And
see.
that's why it is still valuable.
Hmm.
Where just from a unsafe you can during code reviews you can be like, okay, you are doing something wrong over here and I should pay attention to it.
Right.
And that's where I say if validation engineers have to write Rust, they will use a lot of unsafe Rust here and there.
Right.
And that's
Right.
where I say it's better for them to continue writing C language.
Yeah, makes sense because what will happen is it will be C code wrapped around by the Rust code.
Exactly. Exactly.
Which okay, that makes sense. Okay, maybe talk about the second approach, which was like the Rust way. So, is there anything specific about the Rust way to write
So,
Rust, like the default way?
yeah, so Rust way is something I'm trying to learn. So I was able to run writing Rust the C way. I got a
Mm-hmm.
bare metal
Mm-hmm.
board booting up,
Mm-hmm.
and but I was not satisfied that if I have to do this thing, I can do it in C as well. Why should I
Yeah.
go
Yeah.
back and learn such a language?
Yeah.
But writing Rust the Rust way is I would say it's a very unique challenge. So,
Okay.
and specifically if you are, for years you have developed in C, you get habitual to the fact is कि अपुनिच भगवान है.
Right.
And now you have a Rust where compiler tells us you don't know anything, please go and fix it.
Right.
Yeah.
Well, the
And
Rust.
so,
Hmm.
initial days of Rust, when you start programming with Rust, you keep getting like, at least I keep getting very furious at the compiler that it's just
Yeah.
a variable,
Yeah.
let me modify it. But
Yes.
once you start getting habitual to it, you start getting the point why Rust enforces it this way.
Right. Right. Right.
And the thing is, this is not only Rust. A lot of like even C and C++ has these, but these are coding guidelines in C and C++, not
Hmm.
a mandated rule.
Yes.
While Rust
Right. I
is,
was
these are not coding guidelines, I'm gonna restrict it as a rule.
right. I was going to come to that, which is whatever Rust does, which is usually the compile time checks on, the pointers, the bounds, all of those. The C compiler can also do maybe, but these are like various flags, warnings, errors, those kind of flags that you need to
Exactly.
enable specifically. Right? And of course, once it comes to like allocation of memory, I think there's no way for C compiler to go behind that, scan all
Yeah.
of it. Um, well, we do have tools like Valgrind and others, which
Yeah.
can kind of, when run on the C source code, give you a sense of, are you freeing the memory correctly? But I don't know how reliable they are. Um, does it give like a report that's 100% reliable? If any one of you
So,
has used it?
so the point is that a lot of these tools are quite reliable. You run a linter,
Mm,
you run a static time
mm,
checker, then you have Valgrind as well
mm,
looking into
mm,
this. But the
mm.
point is, these are separate tools, right?
Right.
And these are paid tools. Not everybody is going to pay for them.
Well, Valgrind is free, but there are other paid tools. Yes,
There
I
are
agree.
there are other tools which and these are paid tools, and a lot of
Right.
enterprises are not going to pay for that. And
Right.
even if you do it right, somebody like I know Misra, right? And so even though Misra C has guidelines, a lot of guidelines are like mandate
Mm,
uh,
mm, mm,
up to the
mm.
up to the company to follow. Means
Mm.
company can create an exception why they don't want to follow this guideline, and in
Right.
the
And then
report
move on.
mention that
Yeah.
exception and be like, okay, I'm not gonna follow this, and here's my
Right.
reason not to follow this.
Fair. Fair.
You cannot do
Fair.
this with Rust.
Right. Because the compiler wouldn't let you proceed. It wouldn't
Yes,
generate the binary.
and the thing is, there's no extra step here.
Okay.
You run the compiler, and
Okay.
compiler checks all of this for you. While in others,
Right.
you have to
Makes
run
sense.
all these tools separately
Right.
as a part of the
Right.
flow.
Mm.
Right. That makes sense.
Uh, yes. Also, one of the specific things about Rust is, and this is where I see a bit of point. If you look at the trace back of the history, right, Rust started as a language alternative to C++.
I see. Okay. That's interesting.
Because a lot of system programming was happening in C and C++. So Rust is like a low-level language providing you high-level programming constructs. So it has
Mm,
collections like hash maps, etc. built in,
I see.
iterators
I
built
see.
in, generics built
Right.
in, which you will not find in
Right.
C. Actually,
Right.
you will not even find a lot of user even if even a lot of embedded systems are even using these functionalities.
True. True.
Mm.
So the adoption of Rust, where we see majorly it is getting adopted, is places where C++ exists today.
Right. Understood. So
While
Rust is, well, I remember Rust was originally claimed as a systems programming language.
yes,
And then from there, it expanded into like wherever, including embedded now.
yeah. So C was a very bad systems programming language. That's why people
Yeah.
came up with C++. That we
Fair.
need a language that can be expanded, is expandable, and that's why we need object oriented, easy to do object oriented constructs, easy template libraries.
Mm,
You know
mm,
what?
mm.
Let's go to C++. C is not the way, and C found its niche category of the embedded systems,
Mm.
Right. Embedded and
where
in
people
case,
were happy with what
Linux.
was there in C.
Mm, fair. Yeah.
Uh,
Right.
so
Okay. Maybe could you
yeah.
speak to the fact that Rust was able to make its way into the Linux kernel? And could you shed
Uh,
some light on that? And then let's go
so
back to Dave's question of, the concept of borrowing. Go ahead.
yeah. So Rust, and this is where it goes wrong. So I would say I didn't hear about Rust in 2022. I heard about it in
Okay.
2017,
Okay.
actually 2016. So
Okay.
I guess it was at the time of Linux at 25 conference, where interviewer asked Linus Torvalds that a lot of people are interested in Rust. Where do you see Rust? And
Hmm.
Linus did appreciate Rust. He said it's not
Yeah.
a new concept. A
Yeah.
lot of languages have done it in the past.
Right.
And Linus quoted, they were disaster. But he did appreciate Rust a bit, and that
Mm,
was the first instance when I came across Rust. and when
I
I
see.
started reading about Rust.
Mm-hmm.
But I never finished it. And the fact being is because I always tried writing Rust. I never understood why should I write my embedded system code the Rust way while the C way
Right.
works.
Right.
And
Right.
it was not until when I started doing much more higher level programming constructs where a lot of memory management, lot of RTOSs were getting used, where I started
Right.
appreciating maybe the what Rust says is correct. And
I see.
maybe
I see.
using Rust makes sense in certain
Right.
scenarios, not in all
Right.
scenarios, in certain
Right.
scenarios.
Right.
But to the fact, this was 2016 or 2017.
Mm-hmm.
Rust didn't make its way into the Linux kernel. It
Back
just
then,
made its
yes.
way into the Linux kernel in 2023. So even though
Right.
people were aware, people wanted it to be in Linux, it took 6 years for it to come into the kernel. And
Right.
that's where the
Right.
lifespan, and that's where, this goes back to the point that which we had in our first podcast, whether C is dead. And
Yes.
the fact is, you cannot. It just cannot. It's not like today I invent a language and tomorrow it becomes a mainline language. Even
Right.
when
Right.
C came into existence, a lot of the world was still writing assembly till 1990s.
Right.
A lot
Adoption
of
is a
embedded
thing.
systems were running
Right.
directly on assembly. Even C was not adopted right away by embedded systems.
Correct. And what's the what is the journey of a language in terms of adoption? Who
So
adopts it
I think,
first and
yeah.
how does it become
So
mainline?
if we talk about the embedded industry, I usually divide it into three categories. Even though there is a fourth
Right.
category, avionics,
Mm-hmm.
but the major
Mm-hmm.
category I assume is your personal computing, which is your
Mm-hmm.
mobile, desktops, etc. The second one is industrial, and the third one is
Mm-hmm.
automotive. And these
Okay.
goes back into the direction of how much standards are there,
Mm-hmm.
how difficult it is to get changes over there. It's easy to get changes into personal computing because the standards
Right.
are not that strong. The testing of the standards is not very strong. Industrial is a
Right.
bit
Not
hard.
as
Then
much.
automotive
Mm.
is like very high,
Insane.
and then there is
Yeah.
medical and avionics, which is
Right.
like another level.
Mm.
There's
Mm.
that comes to country borders itself.
Right.
So
It
it's
national
usually
security
starts
is involved.
national security. And so it usually starts with personal computing, and that's where we are
Mm-hmm.
seeing a push right now, where people in Android and people in Linux are pushing to have Rust in as part of the main line. And
Fair.
this happened after 7 years, not right away. It's Rust came
Mm-hmm.
up with somewhere in 2010 or 2009 or 2007.
Right.
I am not very sure, but it's not a new language. It's
Yeah. I
a
mean,
quite
I
old
suppose
language.
yes. It took close to a decade to mature, and then after that,
Yeah.
it reached the development community, so to speak, or maybe the wider development community, and now
Yeah.
people are kind of pushing for it. Interestingly, though, I haven't seen a lot of Rust related jobs. Right? That's interesting. So there is buzz, but there are not Rust related jobs yet. Well, not that there are not. There are very few, none that I came across. Um, yeah, I think that's the state of
So
Rust right now.
this
Go ahead.
reminds me of a joke. So there is a YouTube channel I follow, Let's Get Rusty, and in one of
Okay.
his videos, he's like he was making a joke. He teaches the Rust language, and he makes joke. We will learn how to do on-job programming, and he said, "I am kidding. There are no jobs in Rust."
Yeah, which makes sense. Which makes sense. Yeah. Well, I
But actually,
recently.
that's not true. A lot
Yeah.
of people are actually moving towards Rust.
Yes.
Microsoft has a lot of openings in Rust. A lot of companies are writing Rust.
Mm-hmm.
But in embed, they still, like, as I said, right, it's always the personal computing that starts first. Industrial
Right.
follows after very long, and
Mm-hmm.
automotive is like 15 years. If
Right.
somebody wrote any stack for automotive today, they will support it for 15 years.
Right. Right.
And
Right.
Mm.
And
the
C
thing we
stacks are
have to
already
understand
written.
is, yeah, the thing we have to understand is that this is always OEM driven. Semiconductor
Mm.
industries have no interest in driving software innovation.
Right.
They will keep writing what OEM expects because they are not selling software, they are selling the chip. So
Yes.
if let's say today STM decides I will move all my SDK into Rust, and let's say their OEM is Nokia, and Nokia says, no, I want a C stack, STM will be like, okay, let's revert back and write a C SDK
Hmm.
for you, because they have to sell chip. So software innovation doesn't come from them. It is always the OEMs that drive the innovation in software industry.
Right.
AutoSAR didn't come from any semiconductor industry, semiconductor vendor. It came from a group of Mercedes, BMW, etc.
Right. Right.
So unless OEMs push for Rust, it will not.
Hmm.
People will not switch to Rust. And the
Makes
fact that
sense.
goes back, and I keep telling that the tooling across C is very mature. When you are
Hmm.
debugging embedded systems, it's not about your software debugging. You are debugging hardware as well. You need
Right.
debuggers. You need better support for tools, different, and that is not very mature for Rust even today.
Right. Yeah. Yeah. Makes sense.
And the another fact, if you look, if you want to go towards automotive, you need functional safety certification, and nobody is making any
Hmm.
attempt to do that. There is a
Hmm.
list, and this list keeps going on. I guess there is a post, there is again an interview from Linus where Linus says that
Right.
it took them 2 years to get Rust into mainline,
Right.
and he tells about what were the various problems. And so one of the problems I guess they talk about is the standard library of Rust, which is not as modular as C.
Hmm. Hmm.
And when we
Yes.
talk about
Yes.
kernel doesn't have any standard library, right? Kernel implements its own
Yes.
standard library because it
Yes.
cannot rely on things.
Yes.
So it was not very easy for them to decouple the standard library of Rust.
Hmm. I see. I see.
Hmm.
Right.
But there's an
Right.
article, I guess we can put the link to that where Linus talks
Sure.
about it a bit.
Sure. Right.
But yes, so
Maybe.
the stack
Mhm.
is not very mature right now.
Right.
The and honestly, if we go back to the methodology of doing it one way, has never flew across embedded systems. There is
Makes
not
sense.
even a
Yeah.
single standard in embedded systems. Everybody
Yeah.
writes some extensions to the compilers, like GCC. C standard doesn't
Provides its
support
own.
binary format. GCC added the binary format into the compiler to make embedded people's life easy. So there
Right.
is no
Right.
specific standard over here, and this idea of doing it only one way is, I
That's
think,
not,
the more
very
low level you
restrictive.
go, yeah, the
Yeah.
more low level you go, Rust will face the headwinds, and compiler may need to be modified a bit
Mm.
to
Mm.
let
True.
a bit of freedom at those levels.
Right. Right. That makes sense. Well, in between, I was going to call out that I read a post on LinkedIn somewhere, and I kind of don't have the reference to it now. There was a talk about the ISO certification for automotive for Rust. Do you know about
Okay.
that? No. Okay.
Not
Let's
very up
skip
to
that
date.
then. Let's skip that. Fair. Now, okay, let's go back to then the question that Dave had raised, which was around the borrow checker and the concept of borrowing. Maybe we can dwell into that, and then we can call out should or should not embedded systems engineer invest their time in Rust right now,
Hmm.
and then let's maybe roll off and close the podcast for today. Go ahead. Let's talk about the borrow checker.
So the concept of ownership in Rust is like, so whenever you have a memory and you pass that memory to somebody, the Rust says that whoever got that memory now owns that memory, and it is their responsibility to free that memory.
Hmm.
Hmm.
So, for
Okay.
example, if I pass some memory to the other function, so this goes back to the C as well, right? If you have a local variable, its scope ends as soon as the function ends.
Yes.
So, what Rust follows is, as long as the function that created that memory ends, the memory should be freed. It should not
Hmm.
remain in
Okay.
existence. So, what
Fair.
it means is, if you want that memory to remain in existence, you pass it to somebody else. And when that function ends its scope, it frees up. So there
I
is
see.
no
So,
memory dangling there, so which no function is using.
okay. So let's say we have two
Okay.
functions, A and B. A
Yeah,
allocates the memory and passes it to B. So what you're suggesting is if B exits, like after B's
ex-
lifetime is complete, the memory is gone
yes,
unless it chooses to return the pointer back, pointer
exactly.
or whatever reference.
unless it specifically
I see.
passes the ownership back to A.
I see. And how would it pass the ownership? Return? Something like that?
Return. It will
I
return
see.
the
I
variable.
see. And then there was this concept of reference. In case of reference, also same thing happens, or
So in whenever you pass a reference, what happens in Rust is, and this goes back to the concept of mutability and immutability.
I see. I
So
see. Okay, go ahead. Hmm.
so whenever you pass a reference to the code to the another function, you tell whether this reference is mutable or immutable. If it is
Hmm.
immutable, that means the other function can only read it. But if it
Hmm.
is mutable, the other function can modify it,
Hmm.
and it borrows the references. Now the way Rust helps over here is you cannot have multiple mutable references at a given time. There can only be one mutable reference. That means if I pass a memory to some function and then pass it to another function, I cannot pass a mutable reference now. I can only pass, you can have multiple immutable references, but only
I
one
see.
mutable
Okay.
references at a time.
And in case
And so,
of immutable references, the function to which you have passed the reference, its lifespan doesn't dictate the lifespan of
yes,
the memory, right,
you are
of the
not owning
allocation.
the memory, you are just borrowing the memory.
You're just okay looking into it, and you cannot modify
You are
it
just looking.
unless it's a mutable reference.
Yes,
So,
even if you
so
modify, you don't have the ownership of that memory.
I
You
see.
can
Okay.
only, you are just borrowing it. So
Hmm.
what happens over here is, let's say I take a function takes a mutable reference to memory,
Hmm.
and now functions cannot take a immutable reference to the memory, because what if that function modifies the memory? I have a stale memory to it.
Okay. Could you
mm,
repeat that point?
So let's say you have multiple mutable, you gave a functions multiple immutable references that they can read, and multiple threads that are reading from that memory. And suddenly
I
you
see.
now create a thread that takes a mutable reference to it. That means it can
I see.
modify the memory. Now this
Right.
is a
mhm,
race condition, right? Because these are just
Hmm.
relying on the memory that's there, while this guy can change it.
It can free
mm,
free it also, right? Well,
It
it
can
can
free it
just change
also.
it because it's a mutable. It won't be able to free it, right? Because it's a mutable reference and not
Yes.
the ownership is not transferred. So it can change
Huh.
the data, but it cannot free the memory. And now
Hmm.
what you're proposing is if you have, let's say, two such threads, for example, which
Hmm.
take the mutable reference. Now you have a race condition because two of them can
Yes.
write to it.
Yes.
Okay, makes sense. If
okay,
there
but
is one thread that sorry Dave. So
so
if there
what?
is one thread that modifies or has the mutable reference and everybody else just has the non-mutable reference, I think that situation should still be fine because one is updating and others are reading, which is okay.
Mhm.
But I suppose the moment you have two of them having mutable reference to that memory, then it's done. Then you have race condition or potential for it, right? Possibilities of it.
Okay,
Yes.
Go ahead,
so
Dave. You were asking something.
so this scenario can happen, right, where two processes has a mutable reference, and one of
Hmm.
them would have the ownership, right? Not both of them.
Yeah.
Okay.
Oh well, ownership. I think ownership. So okay, maybe I can point out to something, which is if you pass to the function
Hmm.
the parameter or the variable as a reference,
Hmm.
then it only has like access to it. It cannot free that resource. But if
Okay.
you did not pass it as reference, if you just kind of handed over that resource, then the ownership is also transferred to
Transferred.
the
Okay.
𝗁𝗃 function. Yeah. In
Okay.
that case, the end of lifespan for the 𝗁𝗃 function means end of lifespan of the resource, unless
Mm.
the 𝗁𝗃
The
function
returns.
returns back. Yeah.
Okay.
And in fact, a simple example would be, let's say you have mutable A, well, not mutable. Um if you have A and B and you pass it to, let's say, a 𝗁𝗃 function AB, now the existence of A and B is over after that call returns. You
Mm.
cannot reference not reference, but you cannot use the A and B variables again after the
Mm.
𝗁𝗃 function. So that's bizarre as well. Unless the callee function returns back. Now, what I don't recall is whether it can return A and B both, or it can only return A, one value, two value, all of that,
So,
tuple, whatever, list, all of that.
yeah. So I need to go and check back why Rust does it this way. But
Hmm.
actually, you cannot have it. You can either have a mutable reference or any number of immutable references, but not both at the same time.
Oh, at the same time for the current callee function, right? Like A
Yes.
is calling B, and B cannot get mutable and non-mutable reference to a resource, which kind of makes
Yes.
sense. Okay. You cannot not modify it and also modify it at the same time.
Yes.
Okay, it's confusing.
So
Anyways,
either all of you can read it or one of you can modify it.
fair. Okay, that's a. Hmm.
Yeah.
So,
Well, I'm thinking of. Go ahead. Sorry.
it's question in another direction. If you are having the question in on the same topic, then go ahead.
No, go ahead. I think it
Okay.
would be interesting
So,
what you asked.
okay, so typically, we in the software, embedded system software, we need some sort of assembly language instructions to do certain things that cannot be done in C, right? And now when we are, let's say, moving to the Rust, does Rust allow the assembly
Yes.
instructions
Let
to
me
be
guess how
executed?
it might be. Let me just guess how it might be supported. Is it unsafe and then volatile ASM from C and then
ASM, volatile.
Okay.
no? Okay, I think I'll
Yeah,
allow
it's
that. Why not?
supported.
Yeah.
But yes, it so it cannot be all rusty is what.
Yeah,
And if you
yeah,
go and
yeah,
read the embedded Rust book, even they say it cannot be all rusty. There needs to be
yeah,
some
yeah,
patches somewhere.
yeah, yeah.
Okay. And
Right.
does it also allow the C code to be written in,
Yeah.
C syntaxes to be written in Rust somewhere?
So
Yeah.
you can specify a EBI or represent. There's something called REPR representation in Rust, and you can use that keyword to represent a structure in Rust that looks like exactly like the structure of C.
I see. Okay,
So
that is
so
interesting.
you can represent a variable in a different language, and Rust has something called FF. Rust supports FFI, which is foreign function interface. So you can call a C API directly from Rust using that
Hmm.
representation method.
Hmm. Oh yes, I
And
remember now that Rust does allow you to kind of mix C and Rust. And by mix, I mean you can have C files and functions that can be called from Rust, and you can have Rust functions that can be called from C. Much like how we have
yes,
for assembly and C, right?
Hmm.
Yeah.
yes. So it
Okay,
all
that's
goes back to
interesting.
EABI, respecting the EABI. As long as you are respecting the EABI, everything is a binary.
Can you just for our viewers again expand what ABI is or EABI is?
I
Application
guess
binary
EABI
interface.
application binary interface, right? So it's a standard that the processor defines, where if you want to call a processor and I guess language as well in some parts,
Well, I yeah,
define.
let me just expand that out. So the idea is that if you're calling functions, if you're doing function calls, then between the caller and the callee function, there is an agreement as to how the variables or parameters are going to be passed and how the result is going to be returned. And that contract is called the ABI, application
Yes.
binary interface. Yeah. I mean, we could go into details of that in some other podcast. That would be
Yeah.
interesting. Yeah.
Yep.
Perfect. Okay. What else do we have with respect to Rust? Okay, maybe let's go in the direction
So
of
yeah.
the
So
readiness
one
and usefulness for embedded engineers. Go ahead, Raj.
so one amazing thing about Rust that separates it out, and I have said it in the past, I just hate make. And and like a engineer in its mind should not be writing make.
Right, right,
It's very cryptic, and somebody should just rewrite that tool. But a
right.
lot of people still rely on it. Uh,
Hmm.
but one of the amazing things about Rust is its build system. It's a complete package. So Rust has something called cargo, which manages your dependencies. So you just tell cargo that I want XYZ libraries at this version, and cargo will go to its crates repository, bring it in, compile them, and use it.
Right.
So it's a build system of its own, it's a package manager of its own, it's a static checker, static and lint checker of its own. So everything is all packed. You don't have to go to web and look for how to do this, how to do this. Everything is in one simple language. And that's where I
Right.
see, even if you write Rust as Rust in C way, sometimes it still makes sense because cargo is so amazing. You just
Understood. So the
use Rust for cargo.
build
The
system,
build
and
system is really amazing.
right. Cool. Okay. And then, I see that we are around like the 45-minute-ish mark, and maybe we can, now conclude by making some comments about embedded engineers and Rust. Should people go
So
and start learning Rust? Should they keep an eye on Rust? What to do?
So I would make the same comment I made it about DSS. Even though you will end up not writing a lot of DSS, it still makes sense to go back and read DSA because you will understand and at some point try to differentiate why this approach is better than the other approach.
Yeah.
Similarly, I would appreciate that everybody goes back and learn Rust, even though you end up not writing Rust a lot. But what you will get is you will understand why Rust takes this approach. And what
Yeah.
happens is once you start writing code in Rust way, right, you will start writing C in that way as well.
That way. Yes. Yes.
You become by default that borrow checker will get so much cached into your mind that you will by default assume ये नहीं चलेगा. I will write my I have to write code in this way, and
Right.
that just improves you as a developer. So you
Makes
should
sense.
go back and definitely learn Rust. It's a very good language,
Yeah.
and I would appreciate start with Rust in C manner, but then slowly move towards and
Slowly shift
start
gears. Yeah.
read, and the embedded Rust book is a very good reference around it.
Mhm.
Go back
Right.
and read that, and they go back how you can module your low level software so that you can use the high level features of Rust, which is all this borrow
Makes sense.
checker and borrow and ownership concepts on the peripherals
Right.
as well.
Fair. Fair. Okay. So maybe let me do this just in the interest of time now. Uh, Let me conclude by saying that, okay, we don't have so many Rust jobs right now. So maybe, it's okay to not pursue Rust from like a perspective of, getting an employment, but you should definitely try your hands on Rust. And if not anything, Rust will teach you to think more critically, be more mindful of the resources, and reason better about your code. And those skills and mindset are definitely very useful when writing C code as well. So there are no downsides to trying and learning Rust. Would that be
So
accurate?
yeah, so just a funny
Yeah.
thing that reminds me is if you are only a Rust developer giving interview for a job that is C, I remember I used to have a lot of MCQs where it's like what should be the output of this code, and segmentation fault used to be one of the answers. But
Okay,
now
that
the Rust
doesn't hold
developer
anymore.
will now if the Rust developer is doing that who is so habitual of writing Rust, he will just say compile error.
Yeah, that's the
Right.
new error. Okay, okay, new default error. Fair, that makes
Yeah.
sense. Okay, I think then we have pretty
Challenging to
much.
get
Yeah,
it
go ahead.
compiled. Yeah, it's
Yeah.
so challenging to get it compiled.
Oh, I have
Yeah.
Post
tried.
that it
You know,
may not be.
yeah, I've
Yeah.
tried to write few, pieces of code in Rust. The compiler has the ability to make you cry. It will bring you down on your knees. It will do that. But
Yeah.
once you've learned to survive all of that, it definitely makes you a lot
A better
better
programmer.
programmer. Yeah, definitely. It
Mm.
your thinking is so much clearer. Your reasoning is so much better. It just
Mm.
it just forces you to struggle a lot more. Yeah.
Yeah.
Cool. I think would you guys say that we can now conclude the podcast, and maybe we can take
Yeah.
the advanced topics and like a further deep dive in a future session sometime.
Yeah.
Yeah. Yeah.
Cool.
Maybe we
Okay,
can
then
do a complete lecture series on Rust.
sure. Let's do that. Let's do that. Let's do maybe some pair programming kind of something.
Yeah.
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 Yes.
Okay, perfect. Okay, then let's close this call for today. And those of you who have stayed back so long, thank you for doing so, and catch you in the next one. Goodbye.
Yeah.
Bye bye.
Bye.